So I'm just going to go over our end of Unit 4 review for MGS 32. All right, so let's take a look at this warm-up here. In the right triangle ABC shown below, angle C is 90 degrees, AC is 8, BC is 15. The ratio of sine B is, so we go to angle B, okay, and I like to label things, so I know that if I put an arrow here, this is my 90-degree angle, this is my hypotenuse. Okay, this is pointing to my opposite side, opposite leg, and this is my adjacent. Okay, so for sine, right, and you could write right on top of your paper when you get it so you don't forget. So ka and toa. Okay, and so for sine we have opposite over hypotenuse, so we're going to have 15, and we don't know what the hypotenuse is, it's x right now. So one thing we know for sure, oh no, sorry, that's not 15, I just did cosine. Sine is opposite over hypotenuse, right? See, even I make mistakes, and I saw my arrows and was like, ooh, no, wait. Okay, opposite over hypotenuse. And so 8 over something. We don't know what it is. Now, you could find out what something is using Pythagorean theorem. 8 squared plus 15 squared equals c squared. Okay, now that's one way, but you also know, well, 8 has to be on top, so it can't be this, right? And 15's not involved in this, so it can't be anything with 15, right? So it has to be 3, okay? That's a way of doing like quick process elimination, right? Or you can go through the steps, and I'm going to go straight to square rooting 8 squared, right, plus, right, what, 15 squared, right, and that's 17, so 8 over 17, right? Another way, if you're like, I don't remember how to do this equation, you could always go to, I think it's math, go up to where you find numeric solver, so you just go up 1 actually, and you put one side of the equation 8 squared, right, plus 15 squared, and your other side of the equation is x squared because you don't know what it is, and hit OK and hit solve, and you will get an answer for x. X is 17, so C is 17. Okay, so question 1. Given the right triangle in the diagram below, what is the value of x to the nearest foot? So we have an angle here. We know this is the hypotenuse. And we know this is, I'm just going to put H for hypotenuse. And we know this is opposite. That's my arrow. It's a little, here, let me just clean it up. Put an arrow here and an arrow here. Okay. Okay. So we want to know the value of the hypotenuse, and this is our adjacent. So we are given one side, we are given the adjacent side, and the other side we're working with is our hypotenuse, our x, okay? And we are given a angle. So going back to SOHCAHTOA, right, which one is adjacent with hypotenuse in it? Ka for cosine, right? So we can say cosine of 40 equals, right, adjacent over hypotenuse, 14 over x. Okay, now I'm going to actually write that out because I want you to see where the x is and how to do the math. 14 over x. Now, what you're going to do, put a 1 underneath to hold a place value. So then you get x times cosine 40, right? Notice how I'm not finding the cosine of 40. Equals 14. Okay, now I want to get x alone, so I'm going to divide out cosine 40. On both sides. That should say 40, not 4. On the other side. And I'm going to see if I can move this over a bit. And I'm going to move this hypotenuse thing over. I'm going to get rid of that. We don't need it. Okay. So cross this out. Okay, and we get 14 over cosine 40, right? And we put this in our calculator. We do 14 divided by cosine 40. Okay, and in this case, we're looking for a side. We have an angle. Oopsie daisy, what happened here? Well, we know it's not going to be negative. Okay, so let me check. I think something is wrong. What is it? I could imagine that, just like I tell you guys, when I saw the negative, I knew it had to be wrong because I'm looking at distance. I forgot to check the mode, and I need to make sure it's in degrees. So even I forget it, but when you do forget it, there's like certain clues that something is up, like getting a negative for a value that you know you need to get a positive for. So I'm going to go back, highlight my equation, hit enter to copy and paste it, hit enter, and the answer is 18.2. And it says it wants it to the nearest foot, and the nearest foot is 18. So your answer is 3. Okay, so let's take a look. Let me see if I can move this over and move this over. So let's see. Ooh, fancy. I'm learning how to make this smaller. Okay, and I want to make this smaller. Okay, so that way I have plenty of space that you can see what's going on. All right, so we have another right triangle here. In triangle HSF below, angle S is 90 degrees, right? So across from angle S is our hypotenuse, right? HF right here is 30 degrees, the measure is 30, and HF, which is here, the measure is 30, and SF is 23, okay? So we have our hypotenuse is 30, and we have, what is the measure of angle F to the nearest degree? So we're working with angle F, and we're trying to find the measure of the angle. And this is the opposite of angle F. Okay, so I know that this has to be the adjacent. So I'm just going to label adjacent. Okay, and this is hypotenuse. So we're working with adjacent and hypotenuse. That's going to be cosine, right? But we don't know the angle, so we're going to call it cosine, right? And we'll call it cosine theta, because that's our variable when we're working with trigonometry. Okay, try to make this look more like theta. Right, and it's like it's almost like a O in script, right? Cosine of theta is equal to, right, adjacent over hypotenuse, 23 over 30. But we are looking for theta, okay? We don't know what theta is. So to find theta, we're going to use the inverse. operation of cosine, okay, or arc sine. So arc cosine. Let me call it arc cosine because I feel like we've used inverse a lot. Arc cos. And theta is not going to be in there, but 23 over 30 is. Okay. Okay. So that is going to be equal to our theta. Okay, arc cos is just another way to say inverse cosine. Okay, so you are used to seeing it like this, and it's totally fine. It means the same thing. Okay, I just wanted you to see both ways. 23 over 30. And that equals theta. All right, so let's go to our calculator and let's do second cosine to get our inverse, right? And then we're going to do, I believe it's 23 over 30, right? No, wait, sorry. Yeah, adjacent over hypotenuse, 23 over 30. Okay, and that is 39.94, and find f to the nearest degree. 39.9 to the nearest degree is 40 degrees. Okay, let's take a look at question 3. Many roofs are slanted to prevent a buildup of snow, as modeled below. The length of a roof is 5.5 meters, and it rises to a height of 5.2 meters. Okay, so this is our roof. This is the height it goes to, right? And right? And this is the, like, I guess, house or building or whatever. Okay. The angle of elevation, right? Because this is elevating up, right? The angle of elevation of the roof to the nearest degree is, so we're looking for the angle of elevation. That means we're looking at the angle that's down and going up, okay? Depression is going from up to down. We're going from down to up, okay? So we're looking for this angle. And so let's do some labeling. We have here, we have the hypotenuse. And here we have an opposite. All right, so what uses opposite and hypotenuse? Sine. And we're looking for an angle, so we're going to use the inverse or arc sine. But I'm just going to go straight to inverse. I'm doing this all with a mouse, so please be patient with my writing. Sine inverse. Okay, opposite is 2.5. And hypotenuse is 5.5. And so we have sine inverse, second sine 2.5 divided by 5.5. Okay, enter 27.03. Okay, we're going to the nearest degree. We're going to 27, right? Because it's 27. Oopsie. All right, we're doing to the nearest degree. So triangle ABC has a right angle at C, and AC is 7.7, and angle B is 24 degrees. What is AB to the nearest tenth? So I'm going to draw a triangle, right triangle, and this is C because it says that this is our hypotenuse. Okay, angle B is 24 degrees, and angle, we're looking for AB. So no matter what, this has to be AB, right? I just want to, so we have A, B, okay, AC is 7.7. And B is 24. And we want to know what AB is, this x over here, to the nearest degree. Okay, so we have an angle and we have an opposite side, and we're looking for the hypotenuse. That's the first thing I always do. All right, I do my arrows and then I look at what do we have, okay, and what relationship is that, and then what operation am I going to use in that relationship. Okay, so I have my opposite and I'm looking for my hypotenuse. So in this case, we're going to do sine, and we're given the angle is 24. And we know that it's going to equal opposite over hypotenuse. So cross multiply, and we get x times sine 24 equals 7.7. Okay. Now I'm going to make this smaller and move it here. Okay, now I'm going to solve for x by dividing out sine 24. On both sides. Okay, so x equals 7.7 over sine 24. 7.7 divided by sine 24. Okay, 18.9. Oop. Oh, well, 18.9 is there. Okay, because I didn't look at the next number because it's the nearest tenth. Okay. All right, our next three questions. The ramp shown in the diagram below has an angle of elevation, right? It means that the angle is being, right, of elevation. It's from the bottom going up, right, of 4.8 degrees. The ramp is built to a landing 0.6 meters above the ground. Determine and state the length of the ramp to the nearest tenth. So we want to find, right, x to the nearest tenth. We know that this is the hypotenuse. We put that arrow across from the 90 degrees. And then we take our angle of reference and we make a point to the arrow opposite. And it's true, I like to take my arrows actually and make it go all the way to the opposite, so you see. Okay, so we are going to be working in this case with sine, opposite over hypotenuse, and we have sine 4.8 equals 0.6 over x. Okay, now cross multiply. Remember there's a 1 under here to hold the place value, and you get x, right, times sine 4.8 equals 0.6, sorry, 0.6. Then we're going to divide outside. Sine 48. Okay, this crosses out. X equals, and we want to go to the nearest tenth, right? 0.6 divided by sine, it's 4.8. It should be 4.8, not 48. Okay, 7.17, and it's to the nearest 10, so 7.2. Okay, x equals 7.2. All right, let's take a look at the next one. In a right triangle, the acute angle has a relationship sine 3x minus 7 degrees, right, equals cosine x plus 1 degrees. Determine and state the value of x. Now remember, sine and cosine are cofunctions. So whatever sine of theta is, right, whatever that is, that means that cosine, right, it's equal to the angle cosine. It's equal to cosine, and the angle has to be 90 minus theta, right? So now we know that whatever is in here and whatever is in here has to add up to 90. And we also know that because they're the complementary angles, right? So we could set up an equation, 3x minus 7 plus x, plus x plus 1, right? If we add these all up, they equal 90. Okay, now I'm going to combine like terms, and I get 4x, right, minus 6 equals 90. Okay, then I get 4x equals 96. This is because I added 6 on both sides. And then I'm going to divide by 4 on both sides. Whoopsie. Okay, the 4 goes away, and I'm just going to actually just do 96 divided by 4. And that equals 24. So x equals 24. Okay. So let's take a look at the next question. A park ranger needs to secure 2 different trees with wire. A wire is to be attached from a stake in the ground, right? The stake is right here. A stake is like a pointed object that, like a pointed stick, right? The wire is attached from a stake in the ground to each tree. The wire is attached at 2 different heights and 2 different angles of elevation, as indicated by the model below. The park ranger has 20 feet of wire. Does the park ranger have enough wire to secure both trees? Justify your answer. So we need a wire here and a wire here, and we need to know how long, right, the park ranger is going to need. So let's do some marking up and see how to find out the wire for this tree. And we know that this is the hypotenuse, and that's our opposite. Okay, so here we have sine, opposite over hypotenuse, sine 24. I'm going to see if I could type because my hand is actually hurting from drawing here. So let me see if I can type and make this maybe sine 24 equals, right, 4 over x. Okay, so we're going to end up with x sine 24 equals 4. And then we're going to divide out sine on both sides, right? Divide sine. Sine 24. Let me make sure I put that on this side too. Okay, so this gets crossed out, and we end up with x equals 4 over sine 24. And remember to label this opposite. I went a little fast, and this is hypotenuse. Okay, so we have 4 over sine 24. And that's 9.83. So 9.8 and the 3. Yep, 3. I like to use 2 decimal places. Okay. And so let's do the next side. And we have this 90-degree angle, right? So that's the hypotenuse. And we're using this angle of elevation. So this is the opposite side. So opposite and hypotenuse. All right, we end up with, okay, how much of this can I just copy and paste? None. I'll just rewrite it. Okay, we end up with sine 11.6, right, equals 3 over x. Oh, 3 over x. Okay, we multiply both sides by x, and we get x sine 11.6 equals 3. And then we divide out both sides, and we get x equals, right, we divide both sides by sine. Actually, let me put something. Sine, divided by sine 11.6. Okay, so we have 3 divided by sine 11.6. That's 14.92. Okay, so I'm actually going to take this, right, and actually insert, because I like rounding at the end. Do you have to in this case? You could get away without it, but I like rounding in the end. That was 4 divided by sine. Okay, and second, where the delete button is for insert, 3 divided by, okay, and I'm not multiplying these, I'm actually, second, insert, adding. Okay, so I'm adding them together to see if I have enough, and this is actually, something's up here. Okay, delete. This should be 3 over sine 11.6, and this should be 4 over sine 24. And that is 24.75. Okay, so all together, 9.83 plus 14.92. See if that equals the same thing. 9.83 plus 14.92. Okay, 24.75. Yep, the same thing. Okay, this is just with less times rounding, but it's fine to just add up your numbers together, right? And try to stick to 2 decimal points to limit inaccuracy, right? So it'll be more accurate unless you're told otherwise. Okay, so 24.75 is how much wire he needs. So, right, does the park ranger have enough wire for both to secure both trees? No. Okay, and you know that you have to put a full answer. Okay, so this totally doesn't look like an equals. There you go. So we know he doesn't have enough. Okay, the park ranger does not have enough wire to secure both trees because he needs about 24.75 feet of wire to secure both trees. And he only has 20 feet of wire. Okay, that's enough. You don't have to like write a book because that's enough. And you show the math. The math actually supports. So even if you put like the park ranger does not have enough wire, it's because you showed the math there. Okay, so that's it for our review for our exam. And I'll see you guys tomorrow. Bye.